haloalkanes and haloarenes. So haloalkanes and haloarenes, we first note in basic, we are discussing about method of preparation of haloalkanes. So first topic is method of preparation so method of preparation of haloalkanes. So first reactions in this topic, reactions with HX. HX means that hydrogen halides. So in this topic we learn about reactions with the HX means hydrogen halides like HCl, HF, HBr, HI. So first thing, when alcohol react with HX, so alcohol is the reactant molecule react with the HX means hydrogen halides. So in these cases HX break into two part, H plus and X minus according to the homolytic fission. So alcohol HX reagent break into H plus or X minus. After that, a step 1, so R H positive on oxygen atoms, then this is the first step. According to this, so R O, so addition of this hydrogen molecule in OH group. Then after removal of water molecule, step 2 is removal of water molecule by forming of alkyl radical, forming of alkyl carbocations and removal of water molecule. So here this is the chain initiation step. This second step is known as chain propagation step, and third step, after the removal of water molecule, addition of halogen atoms, they formed Rx. So third step is known as chain termination step. So alkyl positive react with halogen negative atoms, they formed Rx. So this is called alkyl halide. This alkyl halide is known as haloalkanes. So where is the possibility? So first step is known as chain initiation, second step chain propagation, third step is chain termination step. This is the final step. So according to the second step, some rearrangement is possible. So according to the process, ROH in the reactions of HX means H positive, X negative. So this is nucleophile. Second is here HX is electrophile. But during the reactions, this is known as protonation. So these protonations, they form R positive by addition of one extra hydrogen on oxygen atoms. So oxygen is unstable after removal of this R positive and water molecules. Then after halogen atoms react on alkyl atoms. So they formed Rx. So here is rearrangement is possible. In these cases, rearrangement possible. So how many types of rearrangement is possible here? After the formation of Rx molecule, so in this rearrangement, so rearrangement means first hydride shift. One important thing is during the formation of alkyl halides, one important thing is hydride shift. So less carbocation move on towards more stable carbocations, like 1 degree shifting in 2 degree, 2 degree shifting in 3 degree, means 1 degree directly shifting in 3 degree, means less hydrogen atoms faster moving on more stable carbocations. Second is methyl shift. So second rearrangement is methyl shift. And third, where is the possibility of ring extension. So ring expansion is also allowed. So first we check on hydride shift. methyl shift, and ring expansion. Let us some example. So let's see the example of first example of hydride shift. So this is alcohol atoms. So this is 1 degree alcohol. So basically this is called 1 degree alcohols. React with the HX molecule. So here HX after the homolytic fissions H plus or X minus. Then after this H plus is added here. So this one extra oxygen atoms added is the OH group atoms. So they formed OH2. After the removal of OH2 molecules, here is the carbocation is formed. So like that, here is positive and removal of water molecule. So one thing, here is the hydrogen atoms. So these hydrogen atoms are shift in the positive charge on carbon atoms. So this is called hydride shift. So this is called hydride shift. So these hydrogen atoms shifted on the positive charge on carbon atoms. So after that, this carbon positive charge moves because this positive charge on carbon atoms is 1 degree, or moved to on the second 2 degree carbon atoms. So after that, this hydrogen for here is positive charge on carbon atoms. So here is the shifted hydrogen atoms. After the this is the second step. Why hydrogen is carbocation is towards on the 2 degree carbon atoms? Because 1 degree is less stable in compared to 2 degree carbocation. So carbocation stability is 3 degree, 2 degree, 1 degree. Then after addition of halogen atoms means this is the chain termination step, or this is the shifted of the hydride shift is called chain propagation step. After that, this negative charge attack on the positive charge of carbon atoms. They becomes so this is the final product of this reactions. So this is the 2 degree haloalkanes is formed here. On the first brief the examples of this type of exam. So 1 degree alcohol after addition of protonation of the hydrogen molecule on the OH group after removal of water molecule, then 1 degree carbocation is formed. So 1 degree is less stable in compared to possibility of arrangement on 2 degree carbon cation. So 2 degree carbocation, the positive charge on shift on 2 degree. So one hydrogen atom shift on the back end of the carbon atom. So this is the chain propagation step. Final step, after the most stable carbocation is formed here, then attack of the halogen atoms, they formed 2 degree haloalkanes. Let's see one example of ring expansion. So this is after the reactions of HX molecule, we use the X replace here chlorine. So after the homolytic fission, H plus is formed and Cl minus is formed. So H plus protonation of the this molecule. So this is becomes like that. So one extra hydrogen added on the oxygen atoms. So oxygen gets positive charge on it. So after the reactions, this is positive charge here and removal of water molecule. Then here is a ring expansion is possible. So here is ring expansion is possible. So how can ring expansion is occur here? So write 1 or 2. Right? 1 or so 1. Then after they formed like that. So here is positive charge. So this positive charge shift on this is 1 degree carbocation shifted on 2 degree carbocations. So here is positive charge shift on one position of the carbon. Then after because initial phase we taking on the 5 member of the ring carbon atoms rings. So they formed 6 member. Here is the ring expansion. Then after chlorine minus atoms attack on the most stable carbocations. So they formed chlorocyclohexane. So during this reactant converted into products. So what is the possibility here? So OH group react on HCl molecule after the homolytic fission of H plus Cl minus. So H plus after the protonation of OH. So add one extra oxygen and hydrogen atoms added on oxygen atoms. They formed OH2. So after the removal of the water molecule, 1 degree carbocation is formed here. So 1 degree tries to convert into more stable carbocations. After that, in this process, here is 5 member of rings converted into, after the ring expansion, converted into 6 member of rings, because 2 degree carbocation is formed. So 1 degree less stable in compared to 2 degree. Then after, chlorine minus atoms attack on the stable carbocations. So Cl minus attack on positive end. They formed chlorocyclohexane. We can write like that. So this is final product. So important point here, we note down. So important points. One important thing, step 1, carbocation formations. Second point, rearrangement is possible. Third point, formation of first carbocations is the rate determining step. So formation of carbocation is known as RDS, rate determining step. So this is known as now. These are the important point. Second method of preparation of haloalkanes is reactions of alcohol in presence of px3. So reactions of alcohol in presence of px3 means like that PCl3. So Rx is formed and H3PO3 is the monoproduct. So now in these reactions there is no requirement of no rearrangement is required here because these are the formation of carbocation is always most stable. So reactions mechanism ROX here 3 moles of alcohol group is required here. Then after px3, so this is the monoproduct. This is the main product. So Rx is formed and H3PO3 is formed. So let's see one examples. So examples here. This is the compound X react with the PCl3. So in this process remove OH molecule and formed this is the final product. Second examples. So this is OH this is the compound A react with HBr. So in case of PCl3 there is no rearrangement is required here, but in case of HX or HBr, HCl, HF rearrangement is possible here. So H plus Br minus they removed here So this is the, in this case, hydrogen shift here these positive atoms. So like that, after the addition of Br molecules, means bromine negatives. So this negative attack on positive charge on carbon atom. So here is, so this is the final product. Next reactions, method of preparation of haloalkanes with the help of PCl5, phosphorus pentachloride. So PXCl replace. So previous we already learned about PX3, now PX5. So in this process RX is formed, then after POX3 is formed, is monoproduct, and HX is formed. So POX3 and HX, these are the byproduct of these reactions. So according to the mechanism of these reactions, ROH react with PX3, or like that X is replaced with taking the example of chlorine. So this is RX is formed, this is HX is formed as a byproduct, and HPOX3 is formed. So RX, POX3 and HX. Let's see some example based on this. PX5 means phosphorus pentachloride. So this is, so are these reactions, first PCl5. So similar to the PCl3 or PX3, there is no rearrangement required here. So according to the PCl5 or PX5, there is no rearrangement is required here. So after the reactions, remove the OH molecules and add Cl. So this is chlorine. Now these reactions, PBr3. After that, bromine atom is added here. Now, these reactions undergo HCl, so rearrangement is required. So after that, OH positive and one extra hydrogen is added on oxygen atom, so oxygen gets positive charge. Then after, this positive charge on it, so this is the stable, because we are try to shift on hydrogen atoms, means hydride shift, there is no possibility required here. So your final product is your final product is chlorine negative charge attack on positive charge of carbon atoms. So this is final product of this compound. Thank you for watching.